Okay, so today we're going to learn about the 30, 60, 90 triangle and also the 45, 45, 90. They're called special triangles. So, by the way, you might want to see a picture of these. I have a couple pictures, I think, in my tools here. Let's see here. We're in a tool bag of stuff. Let's see. Here's a triangle. There's a, this here is a 30, 60, 90 triangle. Okay, and I can rotate it. Check that out. Is that pretty cool or what? So, oh, anyhow, let me grab that. Uh, Hold up. What happened to my? How do I grab it now? Oh, do this. Do this. No. Okay. So, okay. Obviously, I don't know how to get rid of my there. Okay, get rid of it there. Okay. Anyhow, that's the 30, 60, 90 triangle, and anyhow, we're gonna be dealing with those today. So, let's get started. Bam. Look, I did that for you guys to wake you up. Okay. So here's our objective. Those of you taking Cornell notes might want to write this down. If you're not taking up Cornell notes, we'll just move on. So students will be able to find the lengths of the sides of special triangles. How do you find the lengths of a side of a 30, 60, 90? It means 30-degree angle, 60-degree angle, and a 90-degree angle. And this is a 45-degree angle, 45-degree angle, and a 90-degree angle. Okay, so that's what it's referring to. Okay. So here's a little theorem. It says whenever you have a 45, 45, 90-degree triangle, what we have, it says the hypotenuse is square root 2 times the length of each side. So let me give you a picture of what this might look like. So I'm going to try and draw a right triangle. You see, when you have a 45-degree angle here and a 45-degree angle here, it gives you what type of triangle? Isosceles, right? And if the base angles are congruent, then the sides opposite them are congruent. So this side is congruent to this one. So it's isosceles, right? So if you were doing Pythagorean theorem, you'd start off with like A, B, and C here, right? Make sense? But in this case, this is an isosceles triangle. So this side over here is actually, it's actually equal to this one. So those two are always the same. So here's the deal. If we do a squared plus a squared is equal to c squared, then how does this length relate to these two? If you take a look here, if we add those two together, we get 2a squared is equal to c squared. Pay attention. I'm just going to entertain you for a few moments. Yes, sir. And then we'll do a couple examples. Okay? So now if I take the square root on this side and I take a square root on this side, the square root of a square, they cancel, right? So on this side, this square cancels off that, and you actually get c. And this one, we can split up. We could write this as square root of 2 times the square root of a squared. But just like this cancel it off here, a square and a square root, the square and the square root cancel off here. So this square and this one cancel. And so this is equal to the square root of 2 times a is equal to c. You see? That's the result we get. So the point is, if you know this side and this side, then you can get this one. Because all you need to do is multiply by the square root of 2. It's actually pretty easy. So that's what this theorem is saying. If you know the length of the sides, you can always get the hypotenuse by multiplying by the square root of 2. So let's try some examples now, and then I'll let you do your study guide. What I want you to do is we're going to do the first 3 problems on the study guide here in just a moment. So let's try some examples. Ready? Here's an example. All right. Now I want to make some recommendations on this section. Recommendations. Every time you have one of these special triangles, start out by writing the ratios. Okay, so here's what I mean by the ratios. We're told that this is 45. Well, so first of all, I know this one is also, I know this one's also 45 degrees. And I know then that this is isosceles. Okay, so here's what I mean by the ratios. I know it's a 45, 45, 90. So the ratios are going to be A, colon, A, colon, A, square root 3. Those are the ratios. And it's like whatever this side is, this side's the same. That's referring to these 2 legs. And then the hypotenuse is A, what did I put here? That's supposed to be square root 2. My goodness. Square root 2. These are ratios. So this here is referring to the leg. This one is the other leg. Okay. And this side here is the hypotenuse. Okay. Now what do I do on the next step? I put in the information I do know. Like this is one of the legs, right? So this goes in like right there. This one's 12. Well, according to my recipe then, right here, this is my recipe. That's what these are. It's like ratios. Then this side also is 12. Does that make sense? And to get this side here, all I need to do is multiply by the square root of 2. So it's 12 times the square root of 2. There you go. That's the length of your hypotenuse that we're after. Okay? Make sense? Alright. It probably doesn't make sense yet until we do about 500 more of these. Okay, but by the time we do 500 of these, you'll be getting really good. Okay?
I didn't get it.
You didn't get it yet. Okay, let's do another one. Okay, so here's another one. What we want is the hypotenuse, right? So we're trying to figure out this side right here, right? The hypotenuse is always opposite of the right angle, right? So the hypotenuse is over here. Now, how do you know that this is a 45, 45, 90 triangle? Well, you don't yet. However, you do know that this side is equal to this side, right? Which means this is an isosceles right triangle. So this side is congruent to this one. That means that this angle here is congruent to this angle. Well, we know from before that all 3 angles have to add up to be 180, right? And that angle there is 90. So what's these 2 add up to be? 90. And if they're both equal, you have 2x is equal to 90, right? And you divide by 2 on both sides of that equal sign, you get x is equal to 45. And so now you know from basic algebra that this is 45-degree angle. And so is this one. Well, if you have a 45, 45, 90 triangle, it means it's a special triangle. These are special, so you should memorize the ratios of the 3 sides. The ratios I just taught you, well, the 2 legs, A, square root 2. So the point is, if you know this one, then you know that one. You just follow this recipe. This says these 2 are the same, and this one you just multiply by square root of 2. Okay, so which one of these 3 sides, this side here, where does it go? Which one of these 3 is it? Is it this one, or this one?
The second one.
Alright, it could be the second one or the... See, these are the 2 that are the same. So this one's 10 square root 2. That's this one. This one's the other one, 10 square root 2. And how do we get this one? All we have to do is multiply. You see? Multiply by what? Square root 2. No, it says whatever. Look, this is what A is, right? It's the same A that goes there. So in this case, the a is 10 square root 2. But then you have this extra square root 2 that you have to multiply by. You see? So this is just a pattern. You see there's this square root 2. The a, you said, was 10 square root 2. It's the same exact thing right here. Does that make sense? Okay, so now we just need to simplify things a little bit. In this case, square root 2 times the square root of 2 is 2. And we multiply it by 10, we get 20. Okay, so then the ratio looks like this. It looks like 10 square root 2, 10 square root 2, and then this side over here is 20. Because we simplified this. It started out as 10 square root 2 times square root of 2. But the square root of 2 times square root of 2 is 2. So 10 times 2, 20. Okay? This is a little tricky if you haven't done these before. It's just following a ratio. Like, if I have 3 children, and one child is twice the age as the first person, and then the third child's 3 times the age, if I give you any one of the ages, you can figure out the other two, right? Because you either multiply by 2 or you multiply by 3, right? Make sense? That's all you're doing here. You're just kind of following this pattern here. So let's look at your study guide now. Let's see. Well, maybe we should try a couple more examples.
No, we should start.
Yeah, you guys stop whining. Come on. We'll do this example now. Now, if you insist, if you have a right triangle, you could use Pythagorean Theorem if you want. It's slower. Like you can do a squared plus b squared is equal to c squared. You can still do that if you want. Well, this side is x, so we'd square that one. Plus this side, which is x, and we square that one. Okay? And then we take c, which is equal to 15, square root 2, and we square that one. Well, if we add these two together, these two are the same, right?
Yes.
So we get 2x squared is equal to what? This is 15 times 15,
So it'd be 30.
and then square root 2 times the square root of 2. So it's 15 times 15 times 2.
60. No.
I do this in my calculator.
Should be
225
160.
times 2, 450, I think.
What?
Now take a look. What I do then is I divide by 2, divide by 2. And I get x squared is equal to 225. And square root here and square root here, I get x is equal to 15. Okay, that's probably the long way to do it. The advantage of using these formulas is that they always follow the same pattern. According to our ratios, we should have a, square root 2. Now notice that when we go this direction, we multiply. Multiply, right? If you go this direction, you're going to end up dividing. So which of the 3 numbers do we have this time? We have this number, right? It's the hypotenuse, right? Pay attention so you get this. That's this one right here. This is your hypotenuse. Okay? So this goes in right here. This is 15 square root 2. What we need to figure out is this one now. And this one. that make sense? We're trying to figure out these numbers that go right there. Well, all of these are going to have one number. They're related by this formula right here. Okay, I want to share with you a little secret here. Take a look. I'm going to do some erasing. I'm going to rewrite this. You can see a little bit better. We start off with A here. A here.
Your phone's ringing.
I know. I'm ignoring it right now. Okay, I need your full attention if you're going to get this idea. How do you go from here over to here? Well, you have to get rid of that square root 2. Right? If, for example, let's erase here. I've got to erase here. If I have a square root 2 over here, I need to divide by a square root of 2. Right? And if those square root 2's cancel, so you have a left. Does that make sense? That's how you find this one, and that's how you find that one. You need to take this number, whatever it is, and divide by the square root of 2. Okay, so that's how we're going to do this problem. Now watch. I'll start it all over. This is a little bit tricky. Yeah. And so it will help you if you need to watch this over and over again. This is confusing at first. Students really stink at this. So we have a square root 2. This time, this number here is the hypotenuse. Okay? Well, this is the hypotenuse right here. So this is 15 square root 2. So how do I go over to here? Well, according to this pattern, all I need to do is divide by square root of 2. So all you need to do is divide this by square root of 2. And those cancel. And so this number here would be 15. So this would be 15 square root 2. Make sense? You sure? Yeah, sometimes it's easy. Like, let me give you another triangle just to practice, okay? If I have a triangle and it's 45, okay? You ready? If this one's 7, what's this one? 7. What's this one? 7 square root 2. You see? Let's try another one. If I have this one, this is 5. What's this one? 5. What's this one? 5 square root of 2. Okay, you think you got it? You want me to trick you now? Okay, you ready? If this one's square root 3, what's this one? Square root of 3. What's this one? Square root of 3 times the square root of 2, right? Which in this case would be square root of 6. Okay, you guys ready to try another one? Okay, you guys good at this? Think I can trick you? Yeah? So that's 45 degrees here. Okay, what if this one's square root 2? Square root of 2. What's this one? Square root of 2 times the square root of 2. So then you'd have, no. Well, what is the square root of 4 though?
It would just be 2.
That would be just 2. You see? That's the way it is every single time with this. And so, what if I do this one? Alright, let's work backwards now. I made those all easy. What if this one's square root 5? How do I go back to here now? Ah, no.
It would be Nothing equals 5.
Yeah, you gotta figure out. You gotta divide by the square root of 2. See, here's the thing I was trying to say.
So divided by 2.
No. On this one, when we're working this way, what did we do? We multiplied by the square root of 2, right?
Yeah.
You see that? If you go the opposite way, you need to divide by the square root of 2. So that's what I'm trying to say. Look, let's look at this one more time. Here, please remember this because it works on the next ones as well. We're going to learn another special triangle. If you go this way, you multiply, okay? If you go this way, you divide, okay? Divide by what? That. So if you start out with the square root of 5 to go here, you need to take the square root of 5 and divide by the square root of 2. And now a lot of your calculators, you can make sure it's set to math print, and it'll tell you. You don't have to necessarily know your square root properties. A lot of you guys don't know your square roots very well. Square root 5 divided by square root 2. What is that? Well, I'm going to write it in terms of square roots. It's square root 10 over 2. And that means this side over here is square root 10 over 2. Okay? All right, these can be a little bit tricky at first. Luis, you had a question. Are you working on your study guide yet? Well, that's what we did. You got to divide by square root of 2. All right, so let's try your study guide now. I'm going to end the show. No. I'm not ending the lesson. I'm ending this part for a second. I'll pause. Okay, so now we're going to look at the next type of triangle. You guys ready? We did that one. 30, 60, 90 triangle. This one also has a pattern. All right, and the way I would write this pattern is this. You guys ready for this? Yeah, I'm going to write it as A times the square root of 3 and 2A. Now, let me describe to you these pieces of information. This one's the hypotenuse. Okay? Now, you'll notice when we had a 45, 45, 90 that it was isosceles. This one's not isosceles. So there's a short leg. This is the short leg. So this one that's A by itself, that's the short leg. Short. The shortest leg that's up there. Then there's this leg here. This is what I call the medium leg. Like medium size. And this one's the long leg, and of course the longest leg in a right triangle is called the hypotenuse. Now you'll notice something. These two are easy to figure out. One's double the other. Or one's half the other, however you want to think of it. Now to get the one in the middle, you just multiply by the square root of 3. Okay, so we'll start off by doing some easy ones. And we'll gradually get more tricky, okay? You guys ready for this? Alright. Now, once again, you start out by writing the ratios. So I have A. I have A square root 3. And then I have 2A. Now you have to identify which of the three sides do you have. This is 15 goes in where? Here, here, or here? Hold up. It's not the smallest side. It's not the hypotenuse. It's the middle one. So this number here is apparently 15. My question is, I need to figure out that one. And that one. It's not 5. We don't divide by 3. Okay, see, so here's my special little rule. I'm going to teach you a little trick, okay? Pay attention. Pay attention. You'll get the trick. Anytime, hold up, just listen. Anytime you go this way, you divide. Anytime you go the other way, you multiply. Okay? So which way are we going? We need to go back this way, right?
So we divide.
So
by
to
3.
divide. Divide by what?
3.
No, divide by the square root of 3.
Square root of 3.
Okay? So what we need to do is take this number, 15, and divide by the square root of 3. Now, when you put this in your calculator, it will simplify it for you. It's not 5. We're not dividing by 3. We're dividing by the square root of 3. So, square root of 15 divided by the square root of 3. Alright, if you do this in your calculator, you get 5 square root of 3. Alright, so this one is 5 square root 3. Now, I want to go over to this one. This one's easy. What do? You multiply, right? By what?
2a.
By 2.
2.
So if you double this one, what do you get? 10 square root 3. Okay? So this one's going to be 10 square root 3.
We wouldn't multiply 15?
No, because these, you see, this one's A, this one's 2A. So if you have this one, all you need to do is double it.
Oh, okay.
Okay? So again, these are a little bit tricky. Let's try another one because they're so much fun. By the way, we need only do about 500 of these. So we've got about 499 still to do, and then you'll be really good at it. Okay, now this problem. We're going to work it out 2 ways, okay? In one case, we will consider this to be a right triangle with a 45-degree angle. If angle 1 is 45 degrees, then what's this one up here? 45 degrees. That means this side's congruent to this side. In this case right here, the ratios I have are A square root 2. This is the 45, 45, 90. Well, they're going to give you both types of triangles on your assignment, right? So you have to handle both of these. So the first one, let's see, what side do I have though? I have the hypotenuse, which means this one is 100, right? So how do I work backwards? Yeah, remember I told you if you go this way, you have to divide. Divide by what? Square root of 2. So you take 100 and you divide by the square root of 2. If you do that in your calculator, you get 50 square root 2. Okay? Well, no. Only, well, in this pattern, it has a square root of 2 in there. Yeah. Okay, so that means then that this is 50 square root 2. And this one's 50 square root 2. And then this side over here is 100. So that's what it looks like for part A. That's pretty easy, right? Are you guys ready for part B? Part B now. Let me erase this and start over. Okay, so part B, we have a new set of ratios. We're done with part A. We're going to do part B. Now, we're going to say that this angle down here is 30 degrees. Well, that means this one's 30. Now, by the way, let me just make something, help you become aware of something here. It's very important. Since it's important, everybody should be paying attention, right? Remember we told you the 3 ratios is A square root 3, and 2A, right? Where's the biggest angle in here? The 90. This is 90 degrees, right? And you'll notice opposite of that side is the hypotenuse. Where's the smallest angle in here? Over here, right? That means the smallest side is always opposite of that smallest angle. Does that make sense? So that means this is the smallest side here, so that A should be sitting here. And this angle would be 60 degrees. So it's the medium angle, right? So its medium side is always opposite of the angle. So this is where A square root 3 would be here. Okay, that being said, which of the three sides do we have? The hypotenuse. So this one's 100. So how do I get this one? Divide by 2. So this one's 50. How do I go back this way then? Multiply by what? Square root of 3. So that's 50 square root 3. You see how easy this is? It's easy if you know what you're doing. It's really difficult if you don't. So you will have to memorize these patterns. The 30-degree triangle and the 45-degree triangle. What I'd like you to do now is to finish up your study guide. You can have the remaining time, 10 minutes or so, to work on the study guide. And here, we're going to end our lesson